Hello students, so in the last class I gave you an assignment and I have asked certain students to send me the copy of the assignment too. They have done it very nicely. I hope everyone has done that assignment perfectly, because that assignment that we need to keep in our portfolios and all, so you have to keep it safe over there, and whenever it is asked you have to produce it also. It is needed for your internal purposes and all, right? I've already told you about that matter. Okay, so in the last classes we were discussing about the acids, bases and salts. We have discussed many of the reactions of the acids and bases also, and we were discussing about the pH of the solution, right? Several indicators are there to detect the presence of acids and the bases. We can use the indicators to detect the presence of acids and the bases, and we have pH scale to determine the strength of an acid or a base, whether it is stronger one or a weaker one. We have the pH scale also. So that's the point where we have stopped, the pH of the solution. Okay, so we are continuing with that particular topic, acids and the bases pH. We have already discussed, right? We are going to the next part of our chapter, that is salt. Okay, acids, bases and salts, right? Acids and bases, that part is over. Now we are going to the part of salts, right? How we can find out the nature of the salt using the pH matter and all, right? Okay, so that's what we are going to discuss in this session. Okay, watch it, complete the notes. I'll give you the notes also. Complete the notes and study up to date. Be up to date in your studies also. Okay, so we can watch the today's session. Hello students, so we can just go through whatever that we have studied in the last class. So in the last class we were discussing about the pH of the solution. So we were discussing about the pH of the solution. What is pH and for what purpose that we are using the pH? We are using the pH to find out the concentration of the acid or a base. If you want to find out the concentration of acid or a base, we can use the pH. So pH is a scale. So that scale measurement is in between 1 and 14, right? So it has, the scale has a range from 1 to 14. So depending upon the pH value that we are getting, we will be able to find out the concentration of the acid or a base. So if the value of the pH we are getting closer to 1, that means if it is in between 1 and 7, we call them as the acidic solution. So all the acids will have a pH value between that of 1 and 7. Then if you are getting the value of the pH is that value is in between 7 and 14, then we call them as the base. So all the bases will be having a value between 7 and 14, right? So if it is near to 14 means it is a very strong base. But if it is near to 7 means it is a weak base. But the range between 7 and 14 is a base. But when it approaches the 14 value, it is a very strong base. When it approaches the 7, it is a weak base. Now, the same thing for the acid also. So, if you are having a value closer to 1 means it is a stronger acid. And if the value is closer to 7, that means 6, 5 or like that means it is a weak acid. So, if you are getting the value exactly equal to 7 means it is a neutral one. If the value is exactly 7 means it is a neutral one. Okay. So, that is how we are finding out the concentration of an acid or a base using the pH scale. Okay. The more we have discussed is that if your value is closer to 1, that means if the range is between 1 and 7, that means it is an acidic solution. We know that acid contains H plus ions, right? Acid contains H plus ions in it. So, if the value is in between 1 and 7, that indicates the amount of H plus ions. The amount of H plus ions in that solution is very high. The amount of H plus ions in that solution is very high. So, what will happen to the OH minus ions? The amount of OH minus ions will be less, but the amount of H plus ions will be high in case of an acid, right? So we can say that when the value is coming closer to 1, that indicates that amount of H plus ions in that solution is getting increased, whereas amount of OH minus ions in that solution is getting decreased. Now come to the base. So base means it is having a value between 7 and 14. So when it is exceeded the 7 value, that indicates that amount of OH minus ions is getting increased, because presence of OH minus ions is a characteristic feature of a base. So when the value is coming beyond the 7, that means the OH minus amount of OH minus ions are getting increased. So what will happen to the H plus ions? The amount of H plus ions will get decreased also. Okay. So here when you look at, we can say that if it is an acidic solution, it has more H plus ions and it has less OH minus ions. And here in the case of base, we have more OH minus ions and lesser H plus ions. Okay, so this is what we have studied in the last class. So this pH we have studied into find out the concentration of an acid or a base. But we have studied before about the neutralization reaction also. What was neutralization reaction? An acid can react with a base to produce salts, right? To produce salts. So salts are prepared from acid and a base. So acid and a base can react together to form the salt. So we can measure the pH of the salt also. So if we know from which acid and a base that this particular salt is formed, we will be able to find out the pH of those salt also. So that is what we are going to study in this session. How can we find out the pH of the salts? Okay. So we have discussing about the salts. We know that salt is formed from the acid and a base. Hope you remember this reaction. This is a neutralization reaction. Acid and base can react together to give out salt and water. So if we know the strength of acid and base from which the salt is produced, we will be able to find out the pH of the salt also. We can easily find out the pH. pH means whether that salt is of the acidic character or whether the salt is of basic character. A salt can show the properties of an acid or an base. Okay. The salt which is produced over here can show the properties or the characteristics of an acid or a base. So we can easily predict out the character that the salt is showing if we know the strength of acid and the base from which it is produced. Okay. For example, I am taking acid and we can vary the strength of an acid and a base that we are using, and we can predict out the character of that particular salt also. Suppose if we are using a strong, in order to indicate the strong, I am just writing STR, strong. Strong acid, if that salt is produced from a strong acid and a weak base, again weak I am denoting it as just as a W, then the salt which is produced from a strong acid and a weak base, whichever is the stronger one, that salt also will be showing that stronger solution's character. Here it is stronger acid, right? So the salt produced over here will be of acidic character. The salt produced will be of acidic character because it is prepared from a weak base and a strong acid. So what will happen when they are mixing it together? Strong acid means it has lot of H plus ions in it. So even if they are reacting together, the salt produced will be having more, showing more acidic character. Okay, now we can look at just the reverse. If it is prepared from a weak acid and a strong base, if the salt produced is from a weak acid and a strong base, then the salt which is produced will be showing basic character because it is produced from a weak acid and a strong base. Okay, so from a strong acid and a weak base, it will be showing acidic character. If it's a weak acid and a strong base, means it is showing the basic character. So depending upon whichever is the stronger one. Here it is stronger acid, so that is salt is also forming acidic character. Here in the second case, it is a stronger base, so the salt which is produced also will be having a basic character. Okay, then we can just take both of as the strong one, strong acid and strong base. If the salt is produced from strong acid, both the acid and the base, both of them are strong, that means the salt which is produced over here will be neutral. Both are same, both are strong itself, because they have both the H plus ions and OH minus ions in the somewhat higher quantity itself. So the salt which is produced over here will be showing the neutral character. Okay. Then if it is produced from a weak acid and a weak base, both the acid and the base are weaker one, and again the salt which is produced will be showing neutral character. It won't be either acidic nor basic also. Okay, so depending upon if one is stronger and another is a weak, then the salt will be showing that particular character. But if both are having same concentration, that is same stronger one or a weaker one, then the salt which is produced over here will be the neutral one also. Okay, so this is how we predict the characteristics of the nature of the salt which is produced from an acid and a salt, acid and a base. Now we can just check out these certain examples of the salt, and we can find out from which acid and a base it is formed, and hence we can find out whether it is a showing acidic character or the basic character. Okay. Okay students, so I have written some of the examples of the salts on the board. So here are some examples of the salt. Salt means it is produced from an acid and a base. So a particular salt will be having a positive ion and as well as a negative ion will be there. I hope you remember about the ion. Ion is a charged species. So a salt will contain a positive part on it and a negative part also will be there. So positive part, positive ion, we call them as the cation, and negative ion we call them as the anion. These all things we have studied in our last year, right? Hope you remember it. So first example I have taken over here as the K2SO4. So we need to find out from which acid and a base this K2SO4 is produced. Okay. So this each salt will contain two parts on it. So K2SO4. Some ions are familiar for us, right? K is the potassium. We have studied about the potassium ions. K plus ions, right? And we have SO4 also here. Hope you remember it. SO4 means it is sulfate ion. SO4 2 minus, right? So this salt has two parts. One part K2 and other one is SO4. Potassium part is there and the sulfate part. Here one part is made from the, we got it from the acid, and the another part we got it from the base. Okay, it has, each salt has a two parts. One part we are getting from the acidic part and the other one is the basic one. Okay, so we are going to predict out from which acid and a base it is formed over here. Normally an acid, the negative part of the salt will be produced from the acid and positive part is produced from the base. Okay, so first you check it whichever is the positive part over here. K, potassium, K plus, right? SO4 it is 2 minus. So K plus and SO4 2 minus. So K plus means it is produced from K plus and SO4 2 minus. Okay, so we have found out the positive part and the negative part of it. Then normally the positive part will be formed from the base. So predict out a base which contains potassium in it. You have studied many of the base, right? You have studied many of the acids also. From that, can you take any of the example of the base which contains potassium, right? So we can take it as KOH. KOH, potassium hydroxide. Potassium hydroxide is an example for a base which contains K in it, potassium in it, right? So we got the base. Right? Now we need to find out the acid. That acid should contain the negative part, SO4 2 minus. Can you tell me any of the acid with SO4 2 minus, SO4 in it? Right? Yes, it is H2SO4, our sulfuric acid, H2SO4. Right? So acid and a base, we got it. KOH is the base and the H2SO4 is the acid. Right? So when it is reacting together, what will happen? K is here, right? K is here and SO4 is here, right? What is left? A hydrogen over here and OH over here. It will react together and will produce a water, right? So we'll get K2SO4 from KOH and H2SO4, right? KOH and the H2SO4. Now, can you tell me about the Na2SO4? From which acid and a base it is produced? Again, it also contains two parts. Sodium, one part is sodium and another part is again the sulfate, right? So again, we know about sulfate means in all these cases it is sulfate over here, right? So it will be produced from H2SO4. That is clear. Now, other one is Na. Can you predict out any base which contains Na? Right? It is NaOH. 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 NaOH plus H2SO4. Right? Okay. Can you predict out the nature of this? Sodium hydroxide and H2SO4. The acid and the base is the sodium hydroxide and H2SO4. Both of them are very stronger one. Right? NaOH is a very strong base, whereas H2SO4 is a very strong acid. So what will be the nature of Na2SO4? Right? It will be neutral. The salt will be neutral because it is formed from both from the stronger acid and a stronger base. Right? Calcium sulfate, CaSO4. Again, two parts are there. I say SO4 is there. So it will be H2SO4. H2SO4. Now what about the Ca? Can you predict out any base using the Ca? Right? Calcium hydroxide. CaOH twice. Calcium hydroxide. Right? Calcium hydroxide and H2SO4. Okay. Now look at the next example. MgSO4. MgSO4 is a salt which is produced from. Again it contains two parts. You have to divide like that. Okay. Then find out Mg. Using Mg one base. Right? Again you know that MgOH twice, magnesium hydroxide plus SO4. SO4. Which acid it is? H2SO4. H2SO4. Right? Again, the next example. Copper sulfate. Right? CuSO4. Copper sulfate. Again, copper. Again from copper, any of the base. Copper hydroxide. CuOH twice plus SO4. It is H2SO4. H2SO4. Right? The last example that we have wrote over here is NaCl. Sodium chloride. It's a common salt that we are using in our kitchen purposes and all. Can you predict out from which acid and a base our common salt that we are using in our kitchen purpose is made up of? It has also two parts, Na and Cl as that. Na. Can you predict out any base from Na? Right? Again, NaOH. Then Cl is a negative part of here. Cl minus chloride ions. Again, negative means it is prepared from an acid. Right? We got it from an acid. Which acid contains Cl in it? Right? It is HCl, hydrochloric acid. HCl, hydrochloric acid. So likewise, we are finding out from which acid and the base these salts are produced, and depending upon the strength of the acid and the base from which it is produced, we have the NaOH and HCl. Look at that, NaOH and HCl both are stronger one, right? So what will happen to the nature of NaCl? It is a neutral because both are acid and base are stronger. Likewise, we can find out the nature of the salt also. Okay, and each salt is divided into particular families. Family means we know that about the family, right? So when you look at two salts, any of the salts which contains common ions, right? When we look at like Na2SO4, here NaCl is there, right? Na2SO4 and NaCl. Here it contains sodium as a common ion, right? Both of it contain sodium. So we call them as the sodium family. Sodium family, right? Likewise, we can predict it. Here everything contains sulfate in it. So we can all categorize together for its sulfate family. Likewise, if any of these salts which contains common ion in, whether it is a positive ion or the negative ion, we will call them in that particular family name. Okay? It is sodium family over here, sulfate family over here. Nothing else is repeated over here, right? So if it is having the common ions means we'll call them as a particular family. Okay. So I hope you are clear about the salt. Okay. We can just wind up our classes. The salt means salt is produced from an acid and a base. So from which acid and a base it is prepared, we can find out the nature of the salt also. Okay. So far we have discussed about the salts, what is the nature of the salt, and we know that salt is prepared from the acids and bases. Then we have discussed we can find out the nature of the salt if we know the nature of the acid and bases from which it is prepared also. Whether the salt is showing no acidic character or basic character, we can detect from if we know the strength of the acid and a base from which it is prepared also. Okay, and now itself we have understood that sodium chloride is the common salt that we are using in our kitchen purposes and all, right? So we know that sodium chloride, that the salt that we are using in our kitchen purposes, is prepared from an acid, hydrochloric acid, and a base, NaOH also, right? This we have already discussed. We know that the sodium chloride, the common salt that we are using in our kitchen purposes, is prepared from hydrochloric acid and the sodium hydroxide. But you know that large deposition of sodium chloride is seen on the seawater also. So seawater is a main source of sodium chloride. But seawater contains several other salts also present over there in it. Several minerals, a lot of things are present on the seawater. Since these all things are present on the seawater, when we extract out the sodium chloride, right, it contains lot of impurities present in it. Such manner it will be almost brownish in color. Its color will be almost brownish because it contains lot of impurities. Lot of impurities are present on the sodium chloride. Such salt we call it as the rock salt. Such salt we call it as a rock salt. So rock salt is a sodium chloride itself, but it contains lot of impurities present in it. So what will happen to its color? Its color will be, it is appearing as a brownish in color. But sodium chloride is a very industrially important compound because we can prepare lot of other compounds using the sodium chloride as the important raw material. So one of the main important raw material will be sodium chloride. By using sodium chloride as one of the raw material, we can prepare several other compounds also. For example, the same sodium hydroxide we can prepare from the sodium chloride. Like then the bleaching powder that we are using, then the baking powder, right? Then the washing soda, like that several other compounds we can prepare using the sodium chloride as one of the raw material. Okay, so it is a very industrially important compound. The sodium chloride is a very industrially important compound. Okay, so today we are going to study how we can prepare the such compounds using the sodium chloride. Okay. So we can discuss the first compound that we can prepare using the sodium chloride. Okay, sodium chloride. So this is the apparatus setup that we are using for preparation of the sodium hydroxide. So we are preparing the sodium hydroxide using the sodium chloride. Okay, so this is an experimental setup. Okay, so we have in a beaker, I have taken the brine solution. What is brine solution? Brine solution is nothing but sodium chloride itself. Sodium chloride solution. Sodium chloride solution means sodium chloride which contains the water also in it. Okay, sodium chloride mixed with the water. The sodium chloride solution, we call it as the brine solution. So through this area we are entering, the brine solution is entering into this apparatus. Okay, so this apparatus contains two electrodes present in it. What was electrodes? Electrodes are the metals which can conduct electricity. Okay, so these are metals itself, but they are electrodes. So we have two electrodes, we have anode and cathode present in it. Right? So we have dipped two metals which can conduct electricity, we call them as an electrode, into this brine solution. One anode is a positive electrode, then negative electrode as the cathode. Okay, so when the electricity is passed through it, what will happen means, here we have the sodium chloride solution is there. You can see that we have two outlets over here. At the top we have two outlets. Through the one outlet, chlorine gas will be evolved out. Chlorine gas and and the right side again one more outlet is there, through that hydrogen gas will be evolved out also. Okay, so the left side chlorine gas will be evolved out and the hydrogen gas will be evolved out in the right side outlet when the electricity is passed through it. And at the bottom to the right side, what will happen? The brine solution will be going out of this apparatus, and that brine solution will contain our sodium hydroxide also. Okay, so when the sodium chloride means it's a brine solution, when it is undergoing what we call this process as when the electricity is passing through it, we call that process as the electrolysis, right? Electrolysis. So electricity is passed through it. I hope you remember about the electrolysis, electrodes and all, right? So when a brine solution is there, then it is two electrodes are attached to it. When the electricity is passed through it, what will happen? Chlorine gas will be produced, hydrogen gas will be produced, and our brine solution will move away from it, will go outflow out of our apparatus, and it contains sodium hydroxide also. All the products which is formed over here is really important. First we can look at the chlorine gas. What are the main uses of the chlorine gas? Chlorine gas we can use for the water treatment, right? If the water is contain any bacteria, to kill bacteria, we can use the chlorine. We will chlorinating the water, right? Then the swimming pools and all the same things. Swimming pools, that water also should be disinfected, right? It should be disinfected often, right? So we are using the chlorine for disinfecting the waters. For the water treatment, same in the swimming pools. As a disinfectant, again we are using the chlorine, right? Then in the preparation of PVC pipes are there. So PVC is prepared using the chlorine itself. Then CFC, chlorofluorocarbon, CFCs which we are using in our refrigerators and all are prepared using the chlorine itself. And chlorine we can use for the preparation of several pesticides also. Pesticides also we can use the chlorine. Okay, so chlorine is a very important common. The main important use of chlorine is that it is used as a disinfectant, and chlorine also we can use for the preparation of lot of other like bleaching powder and all we are preparing using the chlorine itself. Okay, move on to the hydrogen. Hydrogen is a very good fuel, right? Hydrogen fuel is the right. Then margarine means it's a some sort of dalda, ghee, like that we are using the margarine, that also is prepared using the hydrogen itself. We will be studying that reaction in the coming chapters also. Then ammonia is a very good ammonia which we are using as a fertilizers. For the fertilizers we need ammonia. That ammonia is prepared using the hydrogen itself. So ammonia is also prepared using the hydrogen. So there's also hydrogen is also a very good important product. Then we have the sodium hydroxide over here. Sodium hydroxide has many uses. It is used for the preparation of soaps, like detergents in the paper industries, like is used in the artificial fibers, and certain metals can be degreased using the sodium hydroxide. Sodium hydroxide also has lot of uses. Main uses is that is used in the paper industries. It is used for the preparation of soaps, detergents, as well as the artificial fibers. Okay, so this is how we are preparing the sodium hydroxide. Sodium hydroxide, we can say that sodium hydroxide is prepared using the brine solution. How? By passing electricity through it. Okay, by passing electricity through it. So which are the products over here? Sodium chloride. Then it is a brine solution. So sodium chloride plus water, H2O will be there. It will give chlorine, hydrogen and the sodium hydroxide. Since a chlorine is also produced over here and NaOH is also produced over here. NaOH is a base as well as it is an alkali also. What was alkali? Alkali is a water soluble base. We call it as a alkali. So sodium hydroxide is an alkali and chlorine is also produced over here. Since we call that process as a chloralkali process. Chloralkali process, because an alkali is produced and the chlorine is also produced over here. So this process we call it as the chloralkali process. So brine solution, when electricity is passed through it, chlorine, hydrogen and the sodium hydroxide will be produced. What are the uses of chlorine? It is used in the water treatment, like in the swimming pools, waters and all. is used as a very good disinfectant. It is used in the preparation of PVC, CFC as well as the pesticides. Hydrogen is a very good fuel. It is used in the preparation of margarine, and ammonia, which is a very good fertilizer, is prepared using the hydrogen. Sodium hydroxide. What are the main uses of sodium hydroxide? Is used in the preparation of artificial fibers, soaps, detergents as well as in the paper industries. We are using the sodium hydroxide. Okay, so this is how we are preparing the sodium hydroxide. When the question is coming, you have to draw this diagram also. Show two metals which are acting as an electrode, positive, negative. When set up, brine is entering into it, brine is flowing out of this apparatus. So everything should be there. Okay, now we can just write what is the reaction involved in it. Since I told you that it is prepared using the sodium hydroxide itself, then which all the products are forming, can we balance that reaction and write over here? Then it is prepared using the sodium chloride, right? NaCl. It is prepared using the sodium chloride. It is prepared using the sodium chloride. Then sodium chloride is giving which all products are forming over here? Sodium chloride plus H2O, right? Sodium chloride plus H2O gives NaOH plus Cl2 plus H2, right? So since sodium hydroxide and chlorine is produced over here, since sodium hydroxide is an alkali, we call that process as the chloralkali process. Okay, so I hope the preparation of sodium hydroxide is clear to you. Okay, so in the next class we will study about the preparation of some other compounds also. Okay, I hope it is clear to you. Thank you.